This conference will now be recorded.
All right, so we want to manage in chapter 8. We want to manage using the Stratis local storage. I like to always give some context on where the stuff come from. Right. So let's look up Stratis. All right, so let's look at where that comes from. All right, so Stratis decided blah 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 the motivation behind the changes. Easy to use local storage management for Linux. Um, see if they got any. This is just all release notes. And so with Red Hat Linux stuff that comes out of Fedora is usually connected upstream to Red Hat. It used to be CentOS, but I think they're now going to stick with Fedora. So now let's go back and see if we can see. Stratus is a local Linux local storage management tool that aims to enable use of advanced storage features such as thin provisioning and snapshots, right? And you get this inside of VMware natively, thin provisioning and snapshots, right? All right, so let's go in here and look at what they're talking about. All right, so after this section, you should be able to manage multiple storage layers using local storage management. And it says Stratus is a new local storage management solution for Linux. Stratus is designed to make it easier to perform initial configuration of storage, make changes to storage, and use advanced features. Stratus is available as a technology preview. For information on the scope of this, see features on the technology feature support scope. Let's go over here and check that out. And let me blow that up some. It's actually kind of small. All right. Let's see. They're not fully supported just yet. It's a technology preview. So when you see technology preview, don't use this in production. All right, it's a preview, but in 8.4, it may be stable. So this is 8.2. We're working with 8.4. It may be stable. So you might want to check that out. All right. All right, Stratus runs as a service that manages pools of physical storage devices and transparently creates and manages volumes in a newly created file system. All right, and I want to jump down here and show you how they're looking at Stratus. So you can see here, similar to what we saw with LVM, but here are the physical devices that are located in a pool, and then here's file system 1 and 2. Now, when they say thin pool is say this is 10 gigs, this is 10 gigs, and this is 10 gigs. And this pool may be a total of 30 gigs. But I'm not going to present all 30 gigs. Well, file system 1 is not going to use all 30 gigs, and file system 2 is not going to use all 30 gigs. So let's go back up here and look at it. The file systems are built from shared pools of disks and devices using the concept of thin provisioning instead of immediately allocating the physical storage space to the file system when it's created. Stratus dynamically allocates that space from the pool as the file system stores more data. So it's going to grow on the fly versus I'm going to give it 10 gigs at the file system level and um, that's what it's going to be. And but I may only use 2 gigs. In this case, it's going to just pull from the pool and grow on the fly. That's really what they're talking about there. Um, due to the Strategy dynamic allocates the space from the pool as the file system needs more data. Therefore, the file system might appear to be 1 terabyte in size, but may only have 100 gigs of real storage allocated to it from the pool. And they saying you can create multiple pools. So right here, we could have created multiple pools out of this storage features here or these storage devices here. Remember, see SDC, they're physical devices. All right. And that says, therefore, the file system might appear 1 terabyte size, but unlimited. Okay, you create multiple pools. From each pool, you can create one or more file systems. Currently, you go up to 2 to the 24 file systems per pool. So that's pretty big, right? It says the components that make up Stratis managed file system are built with standard Linux components. Internally, Stratis is implemented as a device mapper. So remember that UDEV and even with device mapper, if you look at using LVM, you'll see /dev mapper and then the logical volume. That's what device mapper is used, and they make reference to it here with LVM, right? You'll see that commonly if you're using LVM. If you just make a partition, you won't see a mapper. It won't be a mapper. It just be the actual /dev and then the partition. And so then they go into the illustration of this here. Now it says now working with Stratis, we're going to do this is manage the file system storage solution, install the Stratis CLI and the Stratis packages. So we have some packages, and it's probably a package for the CLI, right? I wonder what repository this comes from. Well, we're gonna find out inside the class because I'm gonna use the class in order to do this. The Stratis CLI package provides the Stratis command and sends the reconfiguration request to the Stratis D. So there's a daemon that gets installed and probably enabled and ran in order to manage the actual devices and pools. All right. Um, File systems created with Stratis D should only be configured with Stratis D tools and commands. So don't use parted. Don't use fdisk, Joan. Don't use fdisk, because Stratis stores the metadata that's managed by the pools, the volumes, and the file system. All right, so we have to use that. And if you do it manually with a non-Stratis command, it can cause a lot of loss of metadata and probably loss of data is what they're want to refer to there. All right, so you got that. All right. So in the first part, if you're not familiar with how the class is set up, they go through what we call an example of what you're going to do inside of the lab, right? So they're going to install this package right here. And these are the actually two packages you're installing. Remember, we had the -y before, but now we don't have the -y up here. We have it here, so we have to say yes. And then we enable, and this is what I was talking about with Sasha earlier with the -- now. So this enables and starts the actual service itself. All right. And then now we're going to create a pool. So Stratis pool. And if we want to know more information, we can do Stratis -- help or Stratis, a man on Stratis to give us the man pages to see what our options are and what commands we can run with this. So Stratis pool, create me a pool with this virtual device. Look, pool one virtual device VDB. In our case, if you're looking at this, this would be, if we change this to S to a V, it would be VDB. So right now we only got one device. All right, so we're creating a pool with this device, and now it says pool Stratis pool list. Well, the pool name, the actual physical size of 5 gigs, and then a total physical size used. So remember that metadata that they was talking about? That's what that 52 megabytes, or is it megabytes or millibytes, megabytes come into play, the MI. The Stratis pool list command is very important because it shows how much storage space is used and therefore how much is still available in the pools. If the pools run out of storage for the data written to the file system belonging to that pool, it's quietly lost. Key word there, quietly lost. So you need to be constantly checking sizes there. All right, so now they're saying we have another option. So we could do what we call the add data. And this command would add additional block devices to the pool. So first we started with VDB, and now we're going to add VDC to pool one using the add data command. And that's what they're showing there. And then once you get done with that, I will go back and do Stratis pool list so you can see the size as it grows. So here they said use the block dev command to view the block devices. So here they're just showing VDB and VDC of 5 gigs. Then they use the next command, the Stratis file system create. So we don't have a file system. So if we go back and look at what we have to do, we have to create the pool based upon the physical drives, and then we create the file system. All right. So now we're going to create the file system. And now with this particular file system, here they say Stratis file system create. Now by default, I wonder what the file system is. Is it a Stratis file system or is it XFS? This links to Stratis file systems are in Stratis pool 1 directory. The Stratis file system list command is to view the available file systems. Here the file system FS1, here's the size, when it was created, the device, and then there's a UUID that gets created. All right, so here's an important thing to know. The df command will report that any new Stratis file system, XFS file system or 1 terabyte in size, no matter how much physical storage is currently allocated to the file system, because the file system is thinly provisioned. Remember, it's thinly provisioned versus thick provision. The pool may not have enough real storage to back the entire file system, especially if the file system pool is used up. So they're telling you, therefore, it's possible to use up all the space in the storage file pool. So basically, they're telling you don't use the df command. That like the df command is not something you should be using. While the df command is still reporting that the file system has space available, if the pool has no storage available for the file system, further attempts to write to it will be good. So they're saying use the pool list command to monitor remaining storage. Again, don't use your regular commands. Don't use the df commands. Use everything native with the Stratis command. And then it says now you can create a snapshot with the files with the Stratis file system snapshot. Snapshots are just like, hey, I'm grabbing an image in time of the actual file system. Like, you know how you take a snapshot on a screenshot on your computer of what you're looking at that point in time. It's just capturing at that point in time, right? Now I wonder if does this just grow on the fly. We're about to find out. All right, now it says we need to persistently mount. So here we got that ls block UUID. We're going to grab that UUID. And yep, here it is, XFS. We're going to put that UUID inside of FS tab. This is source and then destination. All right. The UUID is the source. Where is it come? What device is it? Slash dir one is the directory we need to create, and that's where it's going to be mounted to. It is going to use the XFS file system, all right? And then remember we had those defaults that we could pass, options, I should say options that we could pass. And it's saying it requires that this x dot s x dash system d service is running. So you have to ensure that that is running, and then 00, right? And they tell you here, and it says mount option delays mounting the file system to after system D starts it, right? So if this isn't started, then this isn't going to get mounted, right? And that's the gist of what they're doing there. And in this case, here's the lab. So how does this work? So we're gonna let's open up service A. I mean not service A, but server A. But I need to open up workstation so workstation can configure it. So if I go back up here to my lab environment, and if I hop onto my workstation, I can just do open console. And it should pop up a console for me here. I don't know where it's at. I don't know why it's saying so slow. Auto stop a minute ago. Oh, no. Stop in an hour. Are we not up? Oh, that's awesome. May have to no, it's not stop. It's on. But it looks like it might have stopped. Let's just reset it. Oh, let's take workstation. And while that does its thing, it'll go away and come back. So let's go back to the class. Let's go back to the course. All right, so in here, We're gonna start the service. We're gonna start this lab environment, and then you're gonna open up on a workstation, and then they're saying you can SSH to the workstation. The reason why you can SSH to the workstation without putting in a username and password, or without putting in a password, is because it's already had key exchanges, public and private keys. The public key has already been exchanged on this particular server. You're then going to switch to root. You're going to do just like they did in the guided exit, or not in the guided exit, in the lab. In the overview of the class, you're going to install the packages, those two packages, and you can put a dash Y after that. You're going to enable the service upon reboot and starting right now. You're going to create a pool using this device. Then you're going to list the size, give you information on the sizing of that device, right? Then once you do that, they're saying, hey, expand the capacity of Stratis Pool 1, which you got created up here, by adding this new device, which is VDC. You're going to expand it. And then again, you're going to do Stratis Pool list, just like I was saying in the class, so that you know that the pool actually grew another 10 gigs, but that's only because this VDC is only 5 gigs, right? And notice what increased too, the physical, the physical, and then the total, right? You see those increased as well too, here versus here, right? And then Stratus block dev list, Stratus pool, list the physical devices, list those block dev devices, right? Block devices is what it is. VDC, VDB, VDC block devices, right? Now what we're gonna do is add a thin provision file system, right? Uh, Name Stratis file system 1 to the pool. Remember, we got the physical device, the pool, and then the file system. So we're working our way up. We did the physical device, we did the pool, and now we're doing the file system. Remember that. All right, so now we're gonna create a file system. It's gonna be called Stratis Pool 1. I mean, we're going to create a file system in the Stratis Pool 1 pool. Double word there, but this is the actual pool name, and here's the file system name, right? Yeah. So Stratis file system, create in the pool, in the actual pool, this file system, and verify that that file system using the Stratis file system list command. So you're going to list it. It's going to give you that it has a file system. Now we're going to give it a directory. Remember, we're setting ourselves up to edit our FSS tab. And now we're going to, here, they're just mounting it manually, right? They're going to mount this entire path to that location. But it's not, if you do it this way, that won't stay across reboots. And then here they're just doing a mount, like show me what's mounted, and they show you how it's mounted. This is the output of that. And then here create a text file called Stratis uh, volume file 1 using the echo command. And so they're they're using this command here, and I verify that the file system Stratis file system 1, and they put it under that particular mount point. It's just a file 1 under that mount point that we got from right here, remember? And they just create a text file and say now verify that the file system, Stratis file system, dynamically grows as the data on the file system grows. So as you continue to write under here, it's going to dynamically grow versus before we set it to have 10 gigs, then it just grows, and then when that 10 gig gives out, then we're automatically growing it. We automatically have to use LVM extend and so forth. This one, it's going to grow dynamically, right? Now, what they're doing here, they want to show you here using the DD command that it just dynamically grows. Now, this is just udev random, and then they're going to say file to BS size and count size. And then you're going to do a list, and it's just going to say the preceding output shows that the Stratis file system has increasing usage confirms that the thin provision has dynamically expanded to accommodate the real-time growth of data. Where this is important is if I want to utilize my storage to its fullest capability, instead of sitting there having a group of people use only 4 gigs of my 2 terabytes, and I, instead of me allocating them 2 terabytes, I create a pool where I allocate them from this pool and this file system. They'll use those 4 gigabytes, but guess what? I may have 4 other teams that can use 100 gigabytes over here and 100 over there and 100 over there. So it's dynamic, right? So it's gonna grow on the fly.
I'm sorry, can
Go
you
ahead.
explain that DD command?
Yeah. Yep.
The
So DD in file, out file. So in file is /dev u random, just some random garbage basically. And then I want you to write out to under that volume that or that file system that we created, right? Stratis volume. I want you to create this file, the byte size and up to this count. That's really what that is. And if you do a man on DD, it'll tell you. So let's go man pages DD. So here BS read and write up to bytes at a time. And then the IF is read from file, basically standard error. In this case, UDEV random. And then OF is write to a file, standard out. And then it was IF, OF, what else I miss? IF, OF, what else I miss? Oh, BS and then count. Let's go to count. And count gives you copy the number of input blocks. So we give it blocks of 2048. Now there's a way you can do this where you can just keep going and it'll just keep counting into infinity, and it'll write till it just runs out of file system space, or write till it runs out of hard drive space, I should say. All right, and then they want you to verify that it's has grown. And then they hop down here that say, now we just want to create a snapshot of that. Remember, I said you always want to back this up. So now they got the snapshot of the file system, right? I mean, of the pool, the file system, and then name the name of the snapshot. All right. So here we're going to say Stratis file system snapshot, the pool, the file system, the name of the snapshot, right? And then they say, give me a list. So now you can see there's a snapshot that has been created. Then you're going to remove the file. They here it said create a directory called Stratis vol/snap. All right, so they create this using the makedir command, and notice that it's not under the entire path. This is at the root level. And now they're saying take that snapshot that you created, and now you can mount that snapshot to that directory. So now confirm that you still can access the file that you deleted from Stratis file system 1 using the Stratis file system. And it says cat Stratis snap file 1. So let's go back up here. We created the snapshot first. Then we deleted the file from the original file system, right? We deleted that file, and then we made a directory of the snapshot. Then we mounted that. But now remember, I told you I backed up that snapshot. It's just a snapshot in time, a point in time of that file system. And that file is still there in the snapshot, but it's not on the original file system. And then they unmount, destroy. They're just right here, they're destroying the snapshot. Here, they're going to destroy the file system and then exit and then reboot. I mean, uh, uh, reset your class. Does that make sense? Did that help explaining it that way? Because you got to go through this when you're in the class or when you do it. Did that help? Or you need to see it? I'm assuming it helped. All right, the next one. Okay, so where thin provisioning comes into play and so forth It's compressing and deduping data. Deduplication meaning if I got a file on the a file that's on the file system, I'm not gonna I'm not gonna compress it and save it twice. I'm just gonna do it one time. So it looks to dedupe and compress the data. And so in here they explain that the rate layer again when we're talking about video and virtual machines, right? All right, so zero block elimination filters out the blocks that contain zeros and records, and this is for backups. This is when you start deduping is when you get into backups and compressing stuff. Deduplication eliminates redundant blocks. When you create multiple copies of the same data, video detects that data that duplication of those data blocks and updates the metadata. Compression is the last phase. In other words, we're going to compress that down. We're going to shrink that down. One thing that's hard to compress are ISOs and DVDs and CDs are hard to compress. They actually blow up when you do it. Ironically, they get larger. All right, so in here they're talking about, well, how do we implement the virtual data optimizer? Now you can see where this comes in handy when we're talking about uh, the data that's shared in these file systems across with different groups. This is where this comes into play. So we have what they call the KMOD and KVDO. Let's go back up here and read some stuff here. All right, the logical devices that you create with video are called video volumes, right? Kind of same logic as we got with LVM. The video volumes are similar to disk partitions, and you can format the volumes with desired type and mount them like regular file systems. You can use video volume as an LVM physical device. The video volume specify a block device and name the logical device that video presents to the user. So again, the physical device, the pool, the file system. Because video volumes are thinly provisioned, users can only see the logical space and is unaware of the actual physical device. If you do not specify the logical size while creating the volume, video assumes the actual physical size, the whole thing, as the logical volume. It's a 1-to-1 ratio. So they're saying here, if you install video stats, it's going to give you information about the logical size, the volume, the physical size and stuff, and monitoring statistics, probably read and write of it. All right, so now here we're going to create a video volume and run the video create. So video create dash dash video one, the device, and then the video size. It says if you emit the logical size, resulting video volume gets the same size as the physical. So if you don't include this as whatever this is, it's going to create it that size. And then they go on to say, here's how you check the status of that video one. All right, checking that status there. And then next, they walk you through compressing and deduping on these devices, right? And that's where they're at. You recognize this, right? You should recognize this. You should recognize this command. You should recognize that command. Remember that mapper I was talking about? That's what I was talking about with the mapper. And they walk you through all of this, all right? And then you finish up. And this should be like implementing the advanced features, like everything from both works from both labs. And then here is a summary. Did that make sense? Let me know. Yes,
Yes.
no. Okay. All right. Is that working out for everybody? Uppercase G, how we doing? Maria, how we doing? Nico, how we doing? Are these explanations? I know it's new and it's foreign, but the way I'm walking through it, does it seem like something that you could um, pick up the way the chapters are laid out? Anybody?
Linux is so new to me, so I'm for now I'm just listening.
That's okay, but the way the chapters are laid out, does it make sense to you?
Not yet.
Okay. So the way the chapters lay out are like here they give you the example of what you're gonna do. They give you some history and some context. And then the guided exercises are there to guide you through what they just got through talking about. And then the labs kind of really much reiterate everything that was covered in the chapter. Does that make sense?
Yeah, yes.
Okay. All right. So when is NFS important? Well, NFS and NFS, auto FS, I should say, is important when you want to say I have a machine or some type of storage unit that has like 15 terabytes and I want to share it with 20 users on one side and 15 users on another side. I can use NFS to share my storage out. And there's other mechanisms you can use to share storage, but right now we're just talking about NFS. So here is a way to share information. You're going to create a mount point. You're going to update NFS. You're going to mount it and then unmount it. And that's the gist of it, right? But just like anything else with Windows, with anything else with Linux, there's packages that you need to have installed and services that you need to have ran, just like with pretty much anything else. So in here, major note that you should note, the default for 8.2 is NFS version 4. There's a difference between 4 and 3. Version 2 is no longer supported. NFS 4 uses only the TCP protocol with the server. Earlier versions use TCP or UDP, and that's important because you can have unnecessary services running on UDP and somebody could sniff your traffic and sniff information out and so forth. So that's why that's important. So basically TCP is your secure protocol and UDP is your unsecure protocol. So that's the difference between the two, and that's why that's important. So you always want to make sure you use the NFS version 4, and also with NFS version 4, it allows you to do authentication with Windows devices as well too. So it has an LDAP component to it as well too for authentication. So here they talk about exporting shares or directories. NFS clients mount an exported share to a local mount point, which must exist. Again, just like with anything else, if you're going to put in an FS tab, it needs to have a directory so that when it comes back up, it knows where to mount that shared drive to. And NFS works over the network. So say Tamika has something inside of AWS and I create an NFS server out there. I give you the host name and the directory to mount. And Sasha, inside of your machine back at on your side, you could mount that directory as long as you have the right permissions that I have set up for that to be mounted to your system, right? I could set that up where you can mount it. I could set it up where only a group of people can mount that. So that's NFS still works with the users or the groups of your operating system, right? All right, so here they get into like, hey, here's the mount command. We've seen that before. At boot time, again, FS tab, and on demand, either make sure the auto FS or the system D auto mount facility is working, right? Faculty of facility, yeah. So what that means is instead of using NFS, because NFS is very chatty, when I say chatty, meaning it's always constantly checking back and forth. So there's a lot of network traffic always flowing back and forth because I'm persistent. I want to make sure that you have no delays in this. So I'm always talking and flooding your file, flooding your logs and so forth. Whereas AutoFS is on demand, meaning like if I'm not using it, then I don't have it mounted. And when I need to use it, I just CD to the directory and then it'll mount it for me, right? So it's on demand, so that I don't have that network flow, that network traffic flow back and forth. I just need to make sure ports are open, but I don't have that need to have it all the time. So it's on demand. So most people use AutoFS. All right. So here they're gonna walk through creating the mount point, mount server B / and then a mount point and then ls mount point. So here they're making a directory, or they're leaving out here really if you're setting up an NFS server. So in here, I don't think on the exam you're gonna have to worry about setting up an NFS server. The server's gonna already be set up. You're just gonna mount the actual NFS server to your device. That's what they're showing here. So you don't have to do that. So here, because it is of NFS, we're going to say mount-t. This gives us a type. NFS and -o gives what options do you want to, how do you want to mount it? I want to be able to read and write. I want to keep the data persistent and syncing, and the location of where it's coming from, the actual share or the actual folder that is being shared out that I can use or that I can mount, and then the mount point of which I want to have it at. That's what that is here. And then if I want that to be persistent, I want you to notice here, FS tab, remember source, destination, the file system, in this case it's NFS. How do you want to, what type of options do you want to have? This could be just read only, it could be write only, but you want read and write. A soft mount, and then of course those 00, I forget the name of those two at the end, I forget the total name of them. And then here you're gonna say mount / and then that mount point, or you can do like I said before, mount -RAV to remount and then unmount, right? And that's the gist. You don't have to set up an NFS server. You just need to understand how to set up, how to remotely mount a particular mount point on from a remote server. And that's what they're talking about here. The unmounted and shared does not remove it from FS tab. Remember, you just unmounted it, but that don't mean you removed it from FS tab. FS tab don't have nothing to do with you manually mounting it. It's just if you unmount it and you reboot it, it's gonna come right back. And then they walk you through a guided exercise on setting up. So there's probably an NFS server that gets set up. Look, see, members of the group admin 1 and sysadmins will have read and write access to this share. And then they walk you through on how to mount that particular server B, which is the entire host name, the shares / public is the directory that's being shared out, the path and the directory that's being shared out, and then where you're mounting it to. And then when you do an ls -cell, it's going to say you should see this information in there. And then it's like, hey, do a mount and then grep for public, because public is the name there, and it's telling you, it's giving you that information. And then you unmount it because you manually mount it. Now you're going to put it inside of FS tab so it can be persistent across reboots. You're going to pretty much do the same thing you did there, except for now you're going to pass it read write. And sync. Up here, notice that you did not pass the -O with the options with read, write, and sync. You could have though, but you're doing that here. And then it says mount / public. And then doing ls, you're getting the same thing. Reboot the system when you come back, because you put in FS tab, it should come right back. And now you're gonna cat notes and then echo some stuff and so forth, and then exit. They're just showing you that you can write to it even across reboots. And that's what they're talking about there. And that's the gist of that lab there. Any questions? No? Okay, so AutoFS, this is gonna be the fun one, right? Because AutoFS works on demand, right? This is, and then they talk about the benefits. You do not need to have root privileges to run the unmount command. NFS configured in an auto mounter are available to all users, machines, subject, and so forth. So with AutoFS, you can now be open up to a machine or user, like another machine can mount it, or there's different objects that you can use in order to use AutoFS. NFS shares are not permanently connected like the entries in FS said, so free networking and system resources. And that's what I was talking about before. And AutoMounter is configured on the client side. No server side configuration is required. AutoMounter uses the same options as the mount command, including the security options. AutoMounter supports both direct and indirect mapping. And they should go over this indirect and direct mapping here. AutoFS creates and removes indirect mount points, eliminating the manual configuration, and NFS is a default AutoMounter network file system, right? And AutoFS is a service that is managed like other system services. So AutoFS is on the client side. So AutoFS needs to be running on the client system in order for it to work. NFS needs to be working on the server side, meaning someone's gonna, or a server is gonna share its resources or its directory out to the world, and AutoFS is gonna look for, is there's a configuration file that you're gonna have to set up, and it's gonna look for that server and say, yeah, you can mount that particular directory onto your system. So we have to install AutoFS. It's a package, right? And then add the master map. So here's Etsy. We again got to configure something. Auto.master.d. So here we're gonna go in here to this one, and we're gonna create a file called demo.autofs. Now in here, remember before they were showing you we did slash something. Here it's gonna be share slash shares, and it's going to read from the Etsy auto demo file. So we're going to configure something in this particular file, right? So when AutoFS starts up, it's going to read this file. Now it said here, we're just adding the master map in this case for indirect mapped mounts, indirect, okay? This entry uses /shares directory as a base for indirect mounts. The auto.demo file contains the mount details used to use an absolute file name called auto.demo. File needs to be created before starting the AutoFS service. So you're going to create this file. In that file, remember we're doing an indirect mapping. You're going to say, hey, work, and then minus RW and sync, and then the server B, basically the server that's serving up the directory we want to share or mount. All right. So the directory that's shared or mounted. So then let's walk through there they give you the format of this. The format of the mount point and mount options, and then the source location. The format is the mount point, the mount options, we've seen the read W and sync, and then the location of where that's coming from, right? This example shows the indirect mounting. So now, known as a key in the man pages, the mount point is created and removed automatically by AutoFS servers. In this case, they're saying that the fully qualified mount point of shares work, and server B is the host name, right? So you'll look up inside of the etc host file or the actual DNS name. It'll be related to an A record or something like that. A record meaning IP address. I mean host name to IP address. That's what that is. All right. It says in this case, the fully qualified mount point shares work. See the master map. The /shares directory and the shares work directories are created and removed as needed by AutoFS. Remember that constant talking that you get with NFS, you don't get that with AutoFS, only when it's accessible, right? Here they have the dash and then you comma separate with no white spaces. That starts with how you set up the options. It says useful auto mounter specific options include dash file system type. So you may have a file system type XFS or something like that, or strict. Use file system to specify the file system type, for example, NFS4 or XFS, and strict to treat errors when mounting the file systems as fatal, right? And then, of course, the last but not least is the source of where it's at. So now when you do a system enable AutoFS, because we're starting it and enabling it, it's going to read, it's going to symlink this information to be enabled on startup. And then they talk about what do direct maps look like. So here's how you do direct maps with the slash dash. All direct maps use slash dash as the base directory. In this case, the mapping file that contains the details are in slash etc auto.direct. So you'll put everything in that file auto.direct, and then you'll mount this. Versus before, instead of using auto.direct, we actually use auto.demo. And in .demo, we named the files with the path that we wanted, right? And here we're using one directory, one file, auto.direct. And it was saying, hey, mount slash dots. Remember the source, not the source, the location of where we want things to be mounted, the options of how we want them to be mounted, and then the load, and then where they're coming from. And they explain it here. The mount point or key is the absolute path of what we want mounted. The rest of the mapping files use the same structure, right? And then you can also do wildcard right here, where the key is asterisk and the subdirectory on the source location is ampersand. And they show you here anything that's going to be anything, everything else in that entry, basically everything else under this shared directory, right? Versus up here, we specified it. And that's what they're showing you in this one. And then they have a guided exercise on that. I would play around with this because this is going to be helpful in a job situation because you'll be running into NFS and AutoFS all the time. And then they have a lab. They go through the lab on this. And then from that, there's the summary. So in today's class, we learned about storage, VDO, where we got thin provisioning to grow on the fly. You also learned about snapshots. You also learned about the volumes, just treat it like you would LVM. And then you learned about not setting up an NFS server, but the client side of NFS from how do you use NFS, then how do you use AutoFS, and then the difference between a direct mount and an indirect mount, and what that looks like. With NFS, depending on how you have your stuff set up, it's just going to show you that mounted directory of whatever size that it is to your local system. You also learned the difference between NFS version 3 and NFS version 4, where NFS version 4 uses TCP, where NFS version 3 uses TCP and UDP. So there's a case and possibility for snooping. Also with NFS version 4, you also get the chance to use LDAP behind it, or what is it not? What is it? LDAP, and then I forget what else they call it off the top of my head. It escapes me. Starts with a K and it'll come back to me. But again, it's NFS version 4 was created because it allows for secure mounting. That's what that comes into play. And I'm going to stop recording now. You can ask your questions.